Hi Pre-Calc, welcome back. Our objective today is going to be to graph rational functions finally, so we're going to put it all together and actually try our hand at graphing some of these by hand. Got the checklist on the screen. However, another thing I would really recommend that you have is all your notes from last time where we really went like point by point of how to find each individual aspect, because we're going to put it all together today. So I'll force pause on the screen. You know what to do from here. All right, so let's go for it. I'm going to force pause on the screen. Can you go ahead and copy f of x in your notes, as well as the 5 aspects I have on the left? All right, next I'm going to ask that you go ahead and factor, but don't cancel yet, but go ahead and factor both the numerator and denominator for me. Go ahead and continue when you're ready to check your answer. All right, so we should have gotten x plus 2, x minus 1 in the numerator, and then x plus 2, x minus 3 in the denominator. So keep in mind that your domain is going to be all real numbers other than negative 2 and positive 3. Okay, so that's the denominator is going to tell you your domain. Okay, so let's take a look at wholes. So we can cancel out these factors of x plus 2. In other words, I can remove that factor of x plus 2. So that's going to be a removable discontinuity. Well, the x value that I just removed from that factor is what? That's negative 2. Okay, so I'm going to have a, again, removable discontinuity at negative 2, which is a whole. Okay, now how do I find the y value? Well, let's just plug in negative 2 for x in the piece that's remaining. So in the numerator, I've got negative 2 minus 1, so that's negative 3. In the denominator, I have negative 2 minus 3, which is negative 5. So cleaning this up, I've got negative 2 comma 3 fifths. So let's go ahead and plot that. So a whole at negative 2 comma 3 fifths, approximately there, right? All right, vertical asymptote. I'm still going to look at my denominator, but remember a vertical asymptote is a what kind of discontinuity? It's a non-removable. So take a look at what's left, was not removed. That is the factor of x minus 3. So the vertical asymptote is x equals 3. So I'm going to go ahead and plot that on our graph. So there's my vertical asymptote. I'm doing each kind of dark tick mark as 1. So this is 1, 2, 3. All right, horizontal asymptote. Do you remember the mnemonic? Bobo Botan eats DC. So do you have bigger on top, bottom, or exponents are the same? They're the same. So divide leading coefficient. So 1 divided by 1. Make sure you put y equals 1 here. Give me an equation of a horizontal line. And then all the work I want you to show here is just tell me what part of the mnemonic you used. So eats DC. So let's go ahead and plot that on our graph. All right, slant asymptotes, this would be none. I can't have, if I have a horizontal asymptote, I can't have a slant asymptote. But remember, a slant asymptote occurs when the degree of the numerator is how much more than the degree of the denominator? Is 1 more, and in that case, you're going to divide. Typically, you can use synthetic division, and you'll just take the quotient, ignore the remainder, and that will be your slant asymptote. All right, intercepts. Well, let's start by finding my x-intercept. So take the remaining part of your numerator, set it equal to 0, and that's going to give me x equals 1, right? So when x is 1, the numerator is 0, and 0 over anything is 0. So I have the point 1, comma 0. All right, and then for the y-intercept, I put 0 in for x and then simplify the remaining part here. So let's come and put a 0 in for this term. So in the numerator, I get 0 minus 1, which is negative 1. And the denominator, I have 0 minus 3, which is negative 3. So cleaning that up, I have the ordered pair 0, comma 1 third. So that's going to be approximately there. Okay, so I've got all the pieces that they asked me for. So now I just kind of need to connect the dots and see what is this graph going to look like. So here's kind of what I want you to be mindful of. Kind of divide your graph anywhere you have a vertical asymptote. So I've got this vertical asymptote at x equals 3. So I'm first going to look to the left of it. So I'm looking in this region here. And I can either have this part come in this first corner, this top corner, like this, or this bottom corner, and approach the asymptotes like this. Well, where are all your points? Let's call it corner A or corner B. Yeah, you only have points in corner B. So if I connect those points, And I can't have them in both corners, right, or I won't pass the vertical line test. Oops, sorry. That was ugly. I'll try that again. So that's what our graph looks to the left of our vertical asymptote. Now let's move to the right of our vertical asymptote. So again, I've got this upper corner here, I'll call this corner A, and this bottom corner, corner B. But notice I don't have any points yet. That's okay, I can find more points if I want to, right? I can plug anything I want in. So let's see, this is 1, 2, 3. Let's see what's happening at x equals 4 to see if I'm on the upper corner or the bottom corner. So I'm just going to come back here to my factored form, and I'm going to plug in 4 for x, so that numerator will be 4 minus 1, which is 3, and the denominator is 4 minus 3, which is 1. So I'm getting the point 4, comma 3, which is in the upper corner, right? So now I see, okay, the kind of second piece, if you will, to this function looks something like this, where we keep approaching those asymptotes. Okay, so this is kind of a rough sketch of our graph. We can always verify on Desmos. And looks like we did good, right? We got the bottom corner here, the upper corner here. By the way, we switched kind of signs, if you will, because we didn't have any even multiplicities. All right, let's analyze domain and range and the rest of the stuff. I'm going to force a pause on your screen. Go ahead and copy what I have. Okay, we're back. So domain, notice we cannot include -2 and +3. And if we come back to our rational function, our equation, we saw that here before we canceled, right? So our domain goes from -infinity to -2, from -2 to 3, and from 3 to infinity, right? Okay, our range, notice that we don't have this y value covered, and if we come back to our hole, remember that y value is 3/5. Okay, so we don't have that y value covered, nor do we have our horizontal asymptote of y equals 1 covered. Everything, all the other y values are covered, so our range goes from -infinity to 3/5, 3/5 to 1, and then 1 to infinity. All right, extrema, any relative mins or max? No, none. All right, and then let's look at increasing, decreasing. As we're in this corner, are we increasing or decreasing? Decreasing. And what about here? Also decreasing. So for increasing, I'm just going to leave that blank, but decreasing from -infinity to that asymptote, right, to 3. And 3 to infinity, all right? And then end behavior, remember this is where we do our limits. So go ahead and write limit as x approaches infinity of f of x, and limit as x approaches -infinity of f of x. All right, and let's find these limits. So for positive infinity, that's when you go to the left or the right? To the right. So as we move to the right forever and ever, are the y values approaching a certain number, or do they go up or down forever? They approach a certain number. What y value are we approaching? We're approaching 1, right? As we continue to move closer and closer, farther and farther to the right, we get closer and closer to that asymptote. Okay, and as we go to the far left, it's the same thing, right? We keep moving, moving, moving. We just get closer and closer to y equals 1. So that's how we write our end behavior. All right, go ahead and force a pause on your screen and copy what I have. See how many of these aspects you can do on your own. I'm going to walk you through all of them again together, but let's just see how many you can do without my guidance. Okay, we are back. Notice that this function is really already factored for you, right? So I don't need to do that. So let's go ahead and find our holes. Okay, so I've got this factor of x minus 1 squared. Does that cancel? It does not. So do you have any holes? You do not, because there are no removable discontinuities, no factors I can remove. No removable discontinuity, remember, is a hole. All right, so now we're going to look at vertical asymptotes. So you take a look at your denominator again, and you say, okay, well, now that I've canceled, if possible, what's going to make the denominator 0 now? And that's going to be x equals 1, right? So that's going to be my vertical asymptote, and I'll go ahead and graph that. All right, horizontal asymptote, what's the mnemonic? Bobobot needs to see, so bigger on top, bottom, or same here? This is bigger on bottom, right? I have a power of 2 in the denominator, or degree of 2. So what is the horizontal asymptote? Y equals 0. And remember, please give me the part of the acronym that you're using. So this is bigger on bottom, 0. So let's go ahead and graph that line. So hopefully you can see it there, but y equals 0 is the x-axis. Slant asymptotes, do we have any? No, if you have a horizontal, you can't have a slant asymptote. But remember, if you do, when we have a slant asymptote, when the numerator's degree is how much larger than the denominator's. When it's larger by 1, and in that case, remember, divide, use polynomial or synthetic division. Whatever your quotient is your slant asymptote. All right, intercepts. Let's go ahead and for the x-intercepts, remember, you make your numerator 0. Can the numerator ever be 0? No, it cannot. So no x-intercepts. Okay, so it can never cross the x-axis. And then for y-intercepts, remember, just find basically f of 0. So put 0 in for x. So when x is 0, the numerator is 1. Denominator is 0 minus 1 squared. Well, negative 1 squared is 1. So I get this ordered pair 0, 1. So I'm going to plot that. And now we connect our dots. Of which I don't have that many, right? So let's again break this up into any spaces that are created with your vertical asymptote. So I have one vertical asymptote. So let's come to the left of it here. We've got kind of this upper corner above the vertical asymptote, and then below. I have 1 point. Is it in the upper corner or the lower corner? It's in the upper corner. So what I'm going to do is approach, oh dear, I'm going to approach my asymptotes in the upper left corner here, right? Okay, now if I come to the right side of my asymptote, again I have this corner above the blue asymptote and below. So what I need to do there, since I don't have any points, is just pick an x value that is to the right of the vertical asymptote. So this is x equals 1, so let's pick 2, okay? So when x is 2, again my numerator is 1, my denominator is 2 minus 1 quantity squared, which is 1 again. So I have the ordered pair, 2, 1 sits right about here. All right, so do we want to be in the upper corner or the lower corner? Upper corner again, so it is going to be this nice reflection. My sketch is pretty rough, but you get the picture, okay? So this is what we get, and the reason we did not switch like from the upper corner to the lower corner is because of the multiplicity here was 2, right? So we don't want to switch signs. Here's maybe a prettier picture with Desmos, so that is that. All right, you all, that's what I have for you today, and I will see you all next time.